Hi, Dr. Rich here. Going to talk a little bit about multiple linear regression, which involves two or more independent variables and a dependent variable, a single dependent variable. That's important. The baseline multiple linear regression assumes that your independent variables are continuous and your dependent variable is continuous. So let's look at how to set this up in SPSS. This is the same data set I've been working with from the customer health scores. I'm going to go up back to analyze. We're still going to use regression and, of course, linear. There are other types of regression that we talked about a little bit before. I didn't go into detail into any of these, but another very common one we use is logistic regression. Logistic regression would be used in the case of a binary dependent variable. So the dependent variable would have a 1 or 0, true or false, etc. But we will stick with your standard multiple linear regression. Here I put customer health score as a dependent variable, and then I can list numerous independent variables like number of participants, revenue 2022, and let me just add a couple more. I am sort of randomly choosing them here, but of course you will choose the variables that are part of your research question and hypotheses. So let's see, days since last activity. Okay, I'll have to update some of these so they are. Okay, let's just go with those. We're gonna leave this as enter. We'll make sure on statistics we have the estimates and the confidence intervals. Model fit is good. R-squared change and descriptives. This second checkbox will come in very handy when you run hierarchical multiple regression. Keep that in mind. Plots, we're going to keep the histogram and the normal PP plot. You can create additional scatter plots if you wish. We do not need all partial plots. Don't worry about that. We don't need anything in there. Not a big deal there. We do not need bootstrapping. And we'll click OK. For our output, we have our descriptive statistics very briefly. Number of participants, we have a mean of 10, standard deviation of 9. Seems to be a big standard deviation if you ask me. We have the average revenue, huge standard deviation. And we also have days since last activity. You'll see the correlation coefficients here. Of course, we have down the diagonal, it's going to obviously be a 1 because it's customer health score. But if we look down, we can see how customer health score is correlated with these other variables, and fairly low correlations. We even have a negative correlation here. So that means as one variable goes up, the other one goes down. Kind of interesting to think about that. This will give you N, which is the number of total records or respondents right here. We have the model summary. We have an R-scored 0.427 for the overall model. We also have R-squared was 0.182. That's 18.2%. That's a pretty low R-squared. You want to think about why that R-squared is low and what that means for your work. Okay. ANOVA means that this found a statistically significant model, meaning the model is good, more or less. And some other information in here as well. Your standard error, your beta, okay, your t-scores, significance. They are all significant, it looks like. And the This is the PP plot and the normal curve, the curve over the data, histogram of customer health score, showing the mean and the standard deviation.